We were just talking about your map of the internet. But who are you?
I'm Barrett Lyon. So
yeah.
Nice to meet you.
Yeah, nice to meet you too.
So
you're the man who mapped the internet. But we're here at BitGravity, which is the company you're working on.
Yep.
Tell me a little bit about you, because you're one of the 3 people who's mapped the internet. And,
I mean, the 3 that I know of. So there's the 3 would be 3 groups. There's Bill Cheswick and Hal Birch at Lumeta that did the original internet map, and then there's the SCADA project. I think that's how they pronounce it, and that is a larger group. And then there's me. So. 2 of those other projects turned into businesses and corporations, and my project has been completely open source and free, and people can use the images for whatever they want as long as it's not commercial without, it's under Creative Commons license, so,
Give me a sense of what you've been doing for the last 10 years, just a little bit, because I see a War Games poster up on your wall, and that sets me.
Yeah.
I'd love to talk to you about that and how accurate that movie was. But you're a security expert, or a network security expert, right?
At one point, if you consider me an expert. Well, obviously, War Games was, as a kid, a pretty exciting movie for me. The internet didn't exist quite yet, as far as the internet as we know it. And BBSs and dial-up modems were kind of the thing at that point. And the movie, for me, kind of got me excited about just the fact that you could sit there at a machine and communicate with other people. So that movie kind of actually gave me a lot of momentum into what I ended up doing with my life. So oddly enough, I was inspired by a movie. So security, obviously, was kind of interesting to me, because you can, if you can outsmart somebody on the network or with software, it's just it's an entertaining game.
Yeah.
It's much more fun to figure out a problem with some software that runs massive infrastructure or something than play a video game and conquer some virtual thing that doesn't exist.
Yeah.
So, I was pretty much an internet addict since I got online, and then there weren't laws or any rules or enculturation process, or even it was all just kind of this open network that people can play with, and you can just kind of have fun with it. And it took a while to learn the etiquette and process, and that there's you might be this 13-year-old kid sitting in your bedroom communicating to something in Australia, and there are real people on the other end of that wire, and understanding that was all new to me, and that was an exciting process, and it really got me interested in security. So I started working for a security consulting firm, which we did work with the first firewall gauntlet. It was when Trusted Information Systems exploded and kind of became Network Associates. And we're doing all kinds of interesting projects with this new PKI encryption thing, building rooms with glass floors and laser beams and all that kind of stuff, and figuring out how to break into things like that. So getting paid to start doing network penetration testing, and then I ended up getting to do a lot of full-time network penetration testing, and then out of network penetration testing, some physical security things like the HID cards that people use to, open up doors and secure bank vaults and things, and figuring out how to, walk into restaurants, copy people's HID information, and then burn your own cards and walk into their office without any security requirements, things like that.
Whoa.
Yeah, so that was all pretty exciting, and
we forget sometimes how open our systems really are, because until you meet somebody like you who knows how to get through some of these systems, because they're not quite closed up.
Well, I'm not very smart, so the thing is, there's a lot of people that are much smarter than me out there, so
yeah.
I'm sure if I could figure out a third of what,
But I just met somebody who can get into your cell phone.
Oh yeah, it's terrifying. If you don't want people to have access to your information, just don't put it out there that's just general rule of thumb. It's on the internet, or on a device that touches the internet. Just kind of assume it public domain if it's that important. But from doing that kind of work,
It's amazing to hear somebody who's expert at the internet say that.
I just gave up. I really just, there's security is, well, the more frustrating part is not necessarily that there's, security is something that you can defeat or you could, secure things very well. The problem is that IPv4 is a protocol that was built for a different environment.
Yeah.
And all security products and even things like content delivery are nothing but like very exquisite duct tape for IPv4. So if you think of it like that, it's kind of sad because all these products and all these
Explain
things.
what you mean, because people are watching. First of all, IPv4 is the internet that we have today, and
Yeah.
IPv6 is the internet we're going to have tomorrow, where every
hope
device
not.
will have its own. Well, and tell me about that,
so-
because we're pretty clueless. But mom and dad at home, we don't know what you're talking about right now.
Okay, so IPv4 is a fantastic protocol. It solved all kinds of problems. But the internet as we know it today is so much of an experiment.
Yeah.
It's very, I'd like to say, it's something that's kind of organically grown from something that it wasn't supposed to be.
Yeah.
And it's done very well because of all these add-ons and bolt-ons and duct tape that enable it to function well. But when you take a step back and you look at it, the internet as it is today is a fantastic experiment. It's exposed all kinds of problems with it, security problems that exist, scalability issues.
Yeah.
IP space is one scalability issue, but others is throughput issues and the ability to transact files much quickly, HD video online, that kind of stuff. And there's no real easy solution to fix that other than rebuild it or think of something better. So when I think about security, I think, well, yeah, you can build a better firewall, you can have encryption, you can have all these types of things, but on the underlying guts of it, you have a protocol that wasn't really built for all that stuff.
Yeah.
So I almost feel that somebody almost like a president would have to say, okay, there's this, we're going to do this. We can go to the moon. We could build a protocol that society can be comfortable with. Because, no one's going to use the internet to vote. Why? Just because your gut feeling is that's a bad idea. Why is that your gut feel? So somebody needs to really make an initiative, like an Apollo-style project, to say, we're going to build a protocol that society can actually use for what society wants to use it for, rather than create all this duct tape and all these like bolt-ons and add-ons to kind of function that way. So
and of course, we're not even close to having that kind of discussion because, first of all, we don't have a CTO in our government. We don't have somebody who the president even can go to and get technical advice from, right?
Yeah.
Second of all, the normal people who are watching my show and you're talking about a language and a system that we just don't understand at its root. Most people don't even understand how their address bar works.
Well, the problem is, with the internet's problem is the internet works well enough.
Yeah.
It does achieve a lot. We're doing a video broadcast thing here. People are going to sit down on the computer, hit play. They can do online banking. But it's all just it could be so much better. And
that brings us today where you're at BitGravity. And what are you doing here today now with all that knowledge that you built up over the last 10 or 15 years?
Well, so previously, before even BitGravity, it was a naive idea of mine, it's a crazy story. There was these, I started doing these kind of, you show up with a briefcase and a tie and we're going to fix your problem. Security problems that, Ghostbusters style, where no one wants to really talk about what's wrong at the company, but we have this thing in the closet we're not going to tell anybody about. So I ended up traveling around fixing a lot of extortion cases to where people were being extorted for $250,000 by some guys in Russia, and basically they're going to shut down their internet business through denial of service attacks, where they basically say, hey, you have a nice mom and pop restaurant, that's how you make your money. We're going to send 250,000 people to your restaurant and they're not going to buy anything and none of your patrons will get in. So they were doing that to people's websites. It exploded in the news. A lot of people know about denial of service now. When I was doing it, it was like kind of like one-off cases here and there. So I started doing more and more and more of those.
You were the defense on these. You weren't the guy who was the bad guy.
I was the guy that they call, and I would show up and spend like 3 days in a chilled data center trying to figure out how we're going to tweak the network to survive these things. And so it became very obvious I needed to build a business that had a huge infrastructure that was designed just for getting the crap kicked out of it. And then the customers can utilize that infrastructure rather than building those infrastructures one-offs for each one of these companies. Just build one massive infrastructure. So that became an entire company. Turns out these denial of service attacks can get quite large. The size of actually shutting down little pieces of the internet and little chunks of carriers would fall apart. And the idea of just being able to defend against those later on seems much more silly than it did when we started. So, while we were there, we worked with law enforcement. We ended up getting 8 Russian denial of service extortion guys put in Russian prison, which they actually are in these little tiny cells and they break rocks during the day. And actually next month me and another guy, we're heading out to Russia to actually meet with them. We have to get these visas and things like that. But the infrastructure we were building there was kind of a reverse CDN. We took all this massive hardware processing ability that would take bandwidth in and absorb it and basically turn denial of service attacks into heat. So instead we're doing the opposite at BitGravity. We've decided that content delivery networks, as they previously existed, were kind of a joke for a modern internet. The Web 2.0 needed a little bit more horsepower. So you have companies like Akamai that were built very well to deliver JPEG images and CSS files and accelerate websites.
Which are little blips, boom, 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 boom.
Yeah, and they take all these little particulates of website and make them very quick. We're built to take the big slab of a video and make that work properly. So the architecture that we put into the network was developed for large file delivery, large objects, long tail storage, and being able to take media libraries and putting them online versus taking image libraries and putting them online. And when you build a network from the ground up with those assumptions, there's a lot of different differentiators and different pieces of the network, and the network gets built much, much differently than, say, an Akamai would be built. Can
you give me some sense of what you did that's different than an Akamai would do?
Well,
is it a different kind of router? Is it a different kind of fiber? Is it?
Yeah, I mean,
or is it a different
all
kind
the
of
above,
software?
I guess. The interesting part is we get the advantage of time, so we got to watch what happened. They're operating, say, 22,000 servers. The average server, based on my math, which I'm probably sure that they're going to say this is wrong, does anywhere from 60 to maybe, I'll be really polite, 200 megabit per server. So if you do the math, the amount of amps and wattage that hardware takes is just extreme. You can run cities off of it. Yeah. And we've decided that our architecture had to use, with the same amount of power, 30 or 40 times the output of what their hardware can do. And when you have 30 or 40 times the output in much smaller, denser spaces, you can use less power and output the same, so your costs go down. And you can deliver high-performance video at smaller costs.
Now, how do you do that 30 or 40 times more data? I'm sure there's some secrets there that you don't want to give away, but give me a sense, and can that be applied to other parts of the internet to make these data centers a lot more efficient?
Well, I mean, yeah, you just take secret sauce packets and you squirt them on your server. There's just so much. PC technology has changed a lot. Yeah. Storage technology has changed a lot. Yeah. I mean, the basics of it haven't changed in 30 years, but a lot of the pieces around it have changed quite dramatically.
Yeah, we didn't have terabyte hard drives 30 years ago.
Yeah, but I mean, the basic hard drive is still a platter that spins at a certain RPM. It has things that read it. And it's got bit rot problems and all kinds of things like that. It's still the same hard drive concept that was built almost 50 years ago. And the same with the CPU, the x86 is like 25, 30 years old or something like that now. It's an old architecture that keeps getting a lot of duct tape. But you could take those technologies and really push them far with newer technologies. Things like new types of RAM, RAM arrays, being able to take all kinds of newer components like 10 gigabit Ethernet instead of using GigE, and then taking TCP offload engines and putting a lot of the heavy lifting pieces in the chips and into RAM and offloading it from the weak parts of the PCs. And you could really design a machine that can output a serious amount of firepower. And then if you go through and you look at storage and you think of, well, we're storing one video might be a gigabyte, and in the future one video is going to be a terabyte, large, depending on bit rates and quality, and terabytes probably not even close. From what I understand, the latest, what was it? The Batman movie took 100 terabytes to store the true, video resolution of the actual video.
Yeah.
So, someday we're going to be required to store that kind of stuff.
Well, I could see an Olympics or a football game where you have 30 HD cameras around the stadium all going at once, and you can choose where you are, right?
Yeah, so I mean, we're going to be
you
taking...
You could spin the camera, you could choose, you probably will have 5 monitors on your wall and be able to choose which camera angles you want to choose from, or you can use a joystick and spin around the stadium. Right?
Or even more intense than that, you have somebody like Justin TV that has hundreds and hundreds of constant streams going all the time, and until recently stored every single one of them indefinitely. So you have these hundreds of people's lives 24 hours a day, just stored. That takes a lot of, scalable storage, and a lot of, it needs to be cost effective to put all of this information online, because, you can put all this data there, but it has to sit there and actually live someplace. Yeah. So, that's been quite a big challenge, and we've designed some pretty amazing storage arrays to accomplish that. So very small, compact things that can, we could put huge amounts of data in them and not require the power that you might think to keep it running. So.
I certainly get the sense of why somebody like you is so valuable to a modern company, a modern startup, or a modern company that has data centers. I mean, the kind of expertise you have is not well understood by a lot of people, right?
Oh, thanks.
Well, I mean, to be able to, I bet you could walk into Google and get a job tomorrow, and and be running rafts of their company, because they need that kind of expertise to build infrastructure, right? And so does a Facebook or a BitGravity, right?
I don't know. I would say Google's a fairly smart company, maybe too smart. But I don't know. I'm either crazy or I have good ideas all the time. I like to brainstorm on things. For instance, one of the biggest problems with a data center is that you lose most of the energy and power, or in cooling.
Yeah.
Most of your energy is used. I don't even know the percentages, like 30% or probably more, goes just into cooling the thing.
Yeah. We were just at HP and saw their data center of the future, where they put sensors on each of the machines, and they try to put the cool air to the machines that actually need it, instead of cooling the whole room, cooling just the machines. And they say they're seeing a pretty sizable increase in
I'm sure.
It's interesting how that's why I keyed in on the techniques you're using to get so much more data through a data center could be used all over the place to save us all energy and keep our global warming problem from
efficiency is kind of the key to making a good content delivery company. So, and as time goes on and gas is more expensive, so does electricity, and it becomes, directly impacts people's pricing and things like that. I mean, a good example, a fun brainstorm session would be, how can we reduce cooling altogether, or eliminate the cost of cooling? And, we'd come up with ideas like, well, why don't we make waterproof cabinets for the servers with, some sort of cooling cycle that can run water through them, and then just submerge our server farms in, hydroelectric producing lakes. And just run the server farm underwater, and then the cooling would be done from the lake water, and the lake water would produce electricity, which would run the server farm. Things like silly things like that, which, I mean, sound kind of absurd, but if it was done right, it could be done.
No, Stanford Linear Accelerator is cooled with water.
Yeah, I mean, water cooling is probably the best way to go. But, it's kind of, for me, it's actually quite frustrating to work for a company that does have a large infrastructure and try to live a very low carbon footprint lifestyle. You walk in these data centers and they have chillers the size of cars on the roofs or bigger, and you don't have much control over that. So it's frustrating. So we do the best we can within our world and try to increase the output to power ratio every day. That's what we try to do.
Well, we've been talking obtusely about the technology.
Sure.
Give me an idea of what BitGravity is doing today and what the outside world will notice. I mean, our show, WorkFast, is broadcast every Friday on BitGravity. Give me a sense of what BitGravity is doing and what people from the outside world would notice that you're doing.
Well, the outside world probably would just notice our logo and a bunch of players. The player technology itself, we develop lots of pieces and parts of players and source code. We give that all the way to our customers for free. What we do is we provide the infrastructure that outputs the video or the files or the streams that you're watching. So to most users, they just experience video and they experience that things just kind of working. They don't really see, the underpinnings of, the infrastructure that's actually running. The actual infrastructure itself is what we call an origin-based CDN. So a big differentiator between what we do and maybe what our competitors do is we don't cache things. We don't have the notion of, well, you have all this data over here, and there's a user group over here that wants it, and we'll just grab pieces of it and keep it near them. What we do is we just keep all of it near everyone at all times. So we'll have massive storage silos in different parts of the planet, or all over the planet. In the U.S., we have half a dozen or more massive storage arrays that are also designed to have massive output performance. And then we manage that all together. So if you're in London and you download a file off of your website, or you're streaming a video off the website, it's actually coming from London, which means that we've reduced a good example is early YouTube. It was all 100% output from California. So you're in London, you hit play, it plays well, but the data comes across, the Atlantic Ocean, it hits the US, goes across the United States, and then it hits the data center in LA or wherever, San Jose, and then the file then streams all the way back. So there's, we call that, very long bit mile range. So you have, many bit miles just to get the data from where it's stored to where the user's watching it. So with us, that backbone action would never happen. The file would be in London. The people would hit play in London and get a very short bit mile. And so when you have the access to the data and you have multiple origins and copies of that data, you can interact with it much quicker. So the end user experience is better because the files are highly available versus sort of highly available. And because we actually have the real content and the full content, you can actually interact with it. So we can build APIs around the video files, or the video game download or whatever it might be. Create security profiles for it. Create unique ways of interacting with it. Create virtual headers, virtual keyframes. In ways that people could build applications around their videos. So instead of having to create 100,000 different encodings in one file, we can have one file. We can tear it apart and put it back together for you while people are watching it. So that's the storage kind of origin-based CDN, and that's kind of its early form. And we have some plans to do some rather amazing things with it. And I think that's something that we'll be talking about a lot next year, or more than talking about. We'll be showing it off. On the other side of the world, we have this live, a live broadcasting system. So we could take a stream off of, say, this camera here, and real-time encode it, broadcast it using a multicast style, broadcast it across our networks to all of our nodes, and then at that point, then redistribute them to the end users. And it runs all through HTTP, which means it's the same protocol that people use for their web pages, and the networks have all been optimized for HTTP.
Yep.
So if we can stream through HTTP, we don't run into all the problems that, say, like flash streaming would run into, which RTMP runs into NAT traversal issues. So the end users have multiple people watching, it screws up their NAT. Or at an
you're using language, and I'm sure I'm losing people. But
well,
but basically, with some of the
if you're at work and your work is very anal about the way they run their security profiles, chances are most of that streaming will not work, and ours will. So it's just a much more fluid type of way of doing it. And as a result, we can do basically a 2-second delay from real time, from us talking to you being on a screen in Australia. And that's pretty unique.
That's pretty cool.
Yeah, and not only is it 2 seconds, it's the ability to replicate that that stream globally and get it to somebody's desktop and interact with it within 2 seconds. And then do that to 500,000 to 1 million people all at the same time.
Wow.
Is kind of cool. So that system is fairly significant. And so that's the other piece of the company that we've been exploring. So.
What's the most viewers you've had test the system out at any one time?
I'm not sure. I have no idea.
Okay.
I mean, definitely in the labs we've done hundreds and hundreds of thousands of streams, or lab tests. Yeah. Customer tests, I'm not really sure, but we've gotten several 100,000 at least. So I'd have to look at some graphs to let you know. It changes day for day. So.
Yeah, that's true. Anything else you want to let us know in the last minute about what you do or what BitGravity is doing?
Well,
or what you're trying to do? Or
I think
products that you're announcing.
Well, yeah, the products. There's not much to announce right now, but we're going to be doing some H.264 stuff here pretty soon with very advanced interactions and our APIs that we have now for FLVs will be for H.264.
That means you can play the video on an iPhone, for instance.
Yeah, or you can we can already do that kind of stuff, but to take it to the next level. But I really think that it's an opportunity for us to change the way a lot of people get entertainment. This year we've seen things go from people just hitting play on video, and that's a big deal, to people going home and having a little box on their set-top box in their living room and hitting play on a remote control and having access to all the video content that ever existed and being able to have instantaneous access to that. That's pretty exciting. And then the next step from that is being able to interact with media in a whole different way. Instead of having just a single producer view of the world, you can have, you're watching NFL or you're watching, any type of sport, and you can decide, I just want to watch the coach cam or helmet cam the whole time. And you can decide and have interactive controls over video, where video is no longer just something you have to watch and take the same director's cut of it. You can actually make your own world and interact with it in that sort of way. So,
yeah, Rocky, you're so fired.
well the great thing about that is it only works when you have good, well-produced video. So.
Yeah. Somebody
just,
still has to show up with multiple HD cameras.
Yeah, we need just more of you now.
Yeah.
See?
You're
okay. So, no, I mean, and that's pretty exciting. We've got a couple applications we've been working on that just kind of demonstrate some of those feature sets. And it's hard for me to kind of explain how it's going to fall or how it's going to unfold, but I have a feeling that the internet seems like it's kind of an old thing, but there's so much that hasn't even been touched yet that it's exciting to see some of those things actually being done while you come to work every day. So that's all I've got for you, I guess. But
well, it's been an honor, and I hope you. We'll do our part to make your your vision of the world, the video world, come to fruition, right?
Yeah, well, at the worst, we'll just get to see multiple angles of my ugly mug here, so.
Might not be as fun for Fast Company TV, but certainly will be fun when you have a football game or an IndyCar race or something like that.
Oh yeah, or like Formula One, things like that. That'll be pretty amazing. The question is, how do we get that into your TV in the living room?
Yeah.
So, anyway, I've got a lot of work to do.